All right, the last few video lessons we've been talking about pressure temperature relationships, saturation temperature, and other properties of liquid. And we're going to delve into that just a bit further, and then we'll get on to refrigerate the refrigerants and how they react. But first, we're going to stay with water. Now, this is key for you to understand as an air conditioning technician. This is the key point for understanding how refrigeration works. So we're going to review here at atmospheric pressure, which is 14.69 psi. Water begins to change state or boil at 212 degrees. Now we can put 2012 degrees of heat apply it to that water, and that water is going to continue to change state, but it will not that water temperature will not raise above 212 degrees as long as it's boiling. And what this chart shows is if we increase the atmospheric pressure on the top of that water, that it requires 228 degrees Fahrenheit of heat energy to have it change state. And the same thing happens if we reduce the pressure on top of that water. It only takes 162 degrees Fahrenheit of heat energy to change the state of that water. So let's just take a look at what happens when we have some water that is at 30 psi of atmospheric pressure above it and 250 degrees Fahrenheit of heat applied. So here's our pressure cooker, and we have it half filled up with water. So down here is water, and up here we have our vapor. The burner, the heat energy being applied is at 250 degrees Fahrenheit. After a time, the water is at 250 degrees Fahrenheit, and up here this is water vapor. It is at 250 degrees Fahrenheit. At this point, this is the saturation temperature that for the water at 30 psi. 250 degrees is the saturation temperature. If we go back and take a look, you can see 30 psi, the boiling point is 250 degrees, and that is what we call the saturation temperature. Now remember, saturation temperature is the point at which the addition or removal of heat will result in a change of state. So we go back here to our pot of water, and we're at the saturation temperature, and the definition again is where any additional removal of heat will result in a change of state. So let's take a look. So here's our pressure cooker one more time. There's our water. Now we just turned this burner up to 251 degrees Fahrenheit. We have added 1 degree of heat energy to this. That definition says if we add heat, it's going to change the state of the water. What it's going to do is that 1 degree Fahrenheit at 30 psi is going to boil and off just a little bit more water and turn it into water vapor. It's still going to be our pressure cooker is going to maintain 30 psi, and it does not matter if we have 251 or 2051 degrees Fahrenheit down here. This water will still remain at 250 degrees Fahrenheit. So if we add the heat, it just boils off a little bit more water, and we end up with less water and more vapor, but everything is still at 30 psi and 250 degrees Fahrenheit. Now let's just drop this down. Let's just take and drop this temperature down. Remember, we had at 30 psi the saturation temperature is 250 degrees Fahrenheit. If we drop this burner and the heat energy down to 249 degrees Fahrenheit, the liquid stops changing state into vapor, but the vapor will start to change state back into liquid, and it will start to beat up and roll down the sides of the pressure cooker and drop back into the water. As long as we have vapor up here changing state back down from vapor to water, and we maintain 30 psi, as long as it's changing state, it is going to remain 250 degrees Fahrenheit. So we can turn that burner up, or we can drop that burner down. As long as we are changing state from liquid to vapor or vapor to liquid, and we maintain that constant pressure, that temperature will always be 250 degrees Fahrenheit. Now, you really need to get this. You need to watch the video over and over. If it just is not sinking in, you need to shoot me a message on the forum, and we will set up a time to make sure that we go through this and you get it exactly. In our next video, we're going to take a look at the pressure temperature chart for some refrigerants, and then it'll begin to understand how we can move heat from inside of a home and remove it to the outside.